Hey there, Internet. So today we're going to be talking about CFD, Computational Fluid Dynamics, internal, external. For internal, we're going to do a mixing sim, and for the external, we're just going to do flow projectile. Okay, first of all, go to Tools, go to Add-ins, and click your flow sim. Then click OK. Mine's already enabled, so that's why I cancelled. And then next step, make your lids. So go to Flow Simulation, go to Tools, create lids, select the face, so you want to click that face basically. Mine's already created, so again, then you would go to Flow Simulation here, go to Wizard, follow the steps, click Next, name your project, next SI if you're metric, US if you're US, or imperial, pick external, internal, pick your liquids or fluids, water, refrigerant. Uh, Again, since I already picked mine stuff, I'm just gonna pick something random and then cancel it out. Wall roughness, if you don't know, leave it blank. If you do, type it in. Your known velocities, type that in. Okay, click finish. Right. So, computational domain is basically the area that you're going to calculate. Well, I'd say volume you're going to calculate really. So if you just pull the arrows, it goes up, left and right, up and down. And then that'll be like the space that you're going to be calculating your flow. Mine's already preset, so I'm just going to cancel out. Okay, boundary conditions, that's basically what's going in and going out. Oh, what's going in mainly. So for mine, it's water and refrigerant 134A. What I did was just right click, select other, pick the face. So I'll just go edit definition. But normally you would just go right click, insert boundary condition. But I already pre-made these, so I'm just going to show you. Basically, right click, select the other net face, and that's how you get that one. And then I pick inlet mass flow. Type in your known values. I just picked some random number here. Substance concentration, so mine is just 100% water, 100% refrigerant. But if you've got a specific mix like 40-50 or 90-10, type that in. Okay, so you would click the tick, and then goals is what you're trying to calculate. I've chosen velocities and flow rates. Okay, so once you've got all those, and then for equation, I'm going to assume that you know fluid mechanics, and you would want to like put in mass in is equal to mass out to confirm it's working, basically. And again, assuming that you know fluid mechanics, you would know what these simulations mean, because it is meaningless if you don't have like the fundamental understanding of fluid mechanics. It looks pretty, but it wouldn't really help you if you don't know. Okay, so you just right click, run. So run takes a few seconds, minutes, depending on your computer's specs. So mine's already done. That's great. Didn't take too long. For cut plots, I recommend sectioning your component, And then for cut plots, you just insert again, and basically it'll give you this, like, so you gotta select the plane, select the contour, and then select what you're actually trying to plot. Okay. Now, I'm just going to show you mine. So play. Now, so blue means low velocity, red means high. Okay, we'll do it again, I guess. Oh, it's auto playing. That's great. So, okay. Now, we'll show. Oh, first of all, we'll clear and hide. Surface plots, we can show. So this is the mass fraction of water. As you can see, the red is 100% water, and then it's 55% refrigerant. And show this one, and that is R-free. So yeah, it's just reconfirming that the refrigerant is about 55%. And flow, so let me just clear them. So my flow, okay. That looks like a total mess because I didn't actually design this properly. It's just for demonstrations. But as you can see, the refrigerant is starting to bottleneck and pile up at this junction. Now the arrows that are spinning, you can see it's starting to mix with the water. So this is the refrigerant going in, and then it's mixing with the water. And you can see that if I optimize the junction, it will reduce the bottleneck, and it will improve the mixing rate. Okay. And particles. So this is to actually simulate what the actual particles would do if it was flowing in. Again, I don't have the specifics of mine, but okay. I already had a pre-made particle. I just made the numbers just default, so it'll probably be a bad simulation. But okay, let me just clear these. Alright. So this is basically what the particles are doing. It looks very similar to the flow trajectories, but this is probably what the particles would do if it's flowing. So as you can see, the particles are going in, starting to mix, and then it's coming back. So it's probably not a good design for pipe work, and so you would optimize that obviously, and you try to improve it. Try to like make this on a different angle, smooth out the bend. Okay, so that's internal mixing, CFD, and now we just got a simple external flow trajectories, and this one is just seeing the velocities, how it flows over. Again, it's just wizard, next kind of deal. Just pick the external, and yep, there you go. Well, you pick your fluid, so that's all the same. Again, computational domain, just size up your area that you want to calculate. Pick your goals, what you want to calculate, and yeah, you just run. Right click run from your project. Again, may take a little while, but mine's alright. It only took a few seconds. Performance varies again depending on your computer's specs. So again, just right click, insert flow trajectories. Mine's already pre-made. I'll show you mine. Okay, so full credit to my friend who made this model. I can't tell you what it is because it is like a NDA sort of thing, but it's something to do with water. That's all I can tell you. Basically, what you're seeing is the flow of water hitting this model, and as you can see, it's orange, which means it's going at quite a fast velocity, and it's slowing down, which means it's having some drag, the blue arrows. And you can see on the sides it's actually speeding up, which means it's increasing in velocity, which means it's got quite a nice shape to it. It's quite optimized well, and it's slowing down because at the end it's gonna cause some turbulence and drag. And as you can see here, it's also hitting that lip of the model, which is also slowing it down. So I'm not gonna comment what he's gonna do, but maybe he could put like an extra lid on top of the lids and make it a bit more streamlined. But again, I'm not commenting on his design choices. I think again, I can't tell you what he's doing, but yeah, that's your basic flow, external flow trajectories. And from what I can see, it looks actually pretty good, with some minor improvements, but overall it's pretty good. Okay, thanks for watching. Be sure to like, subscribe, share with your friends, ring the bell, and comment. Also, have a great day. Until next time, see ya.